Here we have an Asus ROG Strix G731 gaming laptop that came in for repair. Customer brought this in locally, and he said that he was playing the game and then the computer shut off and it would not boot back up. No signs of life, no charging light, no keyboard backlight, and no fan spin. Totally dead. He said at one point he disassembled the laptop to replace the thermal paste, but the laptop worked afterwards. So we can eliminate the fact that it could be something with the disassembly of the laptop. We're going to take a look at the motherboard anyway. We already have the motherboard out right here. Looks something like this. And let's see why the laptop is not powering on and why no signs of life at all. We're going to start with the charging connector. Right next to the charging connector, we have those two DC power MOSFETs. And I've worked on this model many times. We're going to measure at the drain of this MOSFET here in diode mode. We are testing for a short. Oh, it's starting out with a 0.2 voltage drop, but then going down to 0. Look at this. Watch when I put the probe. It takes a while to read a short. It goes to 0.2, 0.1, and 0. Now it's reading immediately 0 voltage drop, but it was not doing that before. So we know that we have a short. Whether it takes a second or two to read a short, we do have a short. And a short on this MOSFET is a very good indication that we have a problem with the V-core circuit of the CPU. When I say V-core circuit, I mean those MOSFETs that you see here. We can verify this by injecting voltage at the short, and then we can monitor the board under a thermal camera and see if in fact we have a heat spot on the MOSFETs or the CPU itself. Heat spot on the CPU does not mean the CPU is bad. It means that we may have a problem with the V-core circuit. But a problem at the V-core circuit could also mean at that CPU. If the CPU received a higher voltage than what it can handle because of a dead or shorted MOSFET, then the CPU may be bad. One of the two options, either a V-core circuit or a CPU issue. Let's power on our thermal camera right here, and we're going to inject 1.5 volts at the shorted component. Viewing a thermal image is like viewing an X-ray. You do not know what's going on unless you do this every day. But I'll tell you, we are basically looking for a heat spot. Right now you do see some heat spots on the board, but those are not heat spots. Those are reflections from shiny objects. You have to be able to differentiate a heat spot from a reflection. Look at what happens when I tilt the board. You see all those reflections are gone, and that's because they are reflections and not heat spots. Take notes. Let's inject voltage at the shorted area of the MOSFET at the drain and see what happens. Look at this. Something is getting hot right on top. Let me do this one more time. You see it? Something is getting hot right here, and that's the CPU. I knew it. We have a problem with either our V-core circuit or maybe our CPU was affected because of the short that we have possibly on our V-core circuit. Let's go back to the microscope, and we're going to measure those V-core MOSFETs and see if we have a short here. We're going to measure at the source of each MOSFET. 0.43 voltage drop, 0.44, 0.44, 0.44, and 0.43. We do not have a short. What if we measure right here? 0.55 all across, 0.54, 56, 56, and we have 56, and then we have 57, and when I say 57 I mean 0.57, not 57 voltage drop. 0.55 and 0.55. Surprisingly, no short anywhere here. And if we do not have a short on those MOSFETs, that also means that we do not have a short on those caps, because any short on those caps will show up here and eventually show up right here where we measured. So nothing is short into ground right here, but we do have the CPU heating up under the thermal camera. And what's under this? Not much. You know what? Let me flip the board. I know we have more MOSFETs on the back. It's usually the front MOSFETs that short, but we do have more MOSFETs right over here. .46 voltage drop, 0.46, 0.46, and oh, we have a short right here. Last one. Wow. Why does it always have to be the last thing that we measure is the one thing that is bad? We got it. Wow. And this one is the 4C09B. We have the 06B, we have the 08, we have the 10. Which one is this? From a donor board. I have a donor board right here, and maybe we can extract it from this donor board. 09B, perfect. But let's measure to make sure the MOSFET on the donor board is good. Very good. Before we grab it from the donor, let's take the customer's bad MOSFET out of the board. We're gonna prep the board, and then we remove it from the donor and put it straight on the already prepped motherboard. Why aren't you using Flux when desoldering ICs off the board? You can, and Flux will probably make it faster because it helps with the flow of solder. But it's only a difference of 1-2 seconds, so not a big deal. Now we can grab a MOSFET from the donor board. Donor board out. And let's go back to the customer's board. Let's make sure drain is on the top as we have the board oriented. And Big Boss just put a video card, Nintendo Switch, Minimax tuner, and a desktop motherboard on my bench for repair, expedited service. So after this board is done, I'm gonna work on another one and probably not combine both of them in one video because I do not want to have a complex title, Asus repair and video card repair in the title. So I'll make separate videos. And we're done. So now I can hand the board to Big Boss to reassemble and test, and hopefully that's a fix, assuming our CPU is good and it did not get affected by the short. What are the chances that the CPU was affected by the short? Based on my experience working on these type of shorts, I would say maybe about 30% chance. I would say I have 70% success rate working on Asus laptops. And the board is back like new. Why isn't it the same as factory? Because it's better than factory. And let's measure right here. And do we still have a short here? And no, we have a voltage drop of 0.375, and this reading is going to go up to about 0.45. Right now it's 0.382, 0.384, and it's going to reach around 0.4. Perfect. So I'm going to give the board to Big Boss to reassemble and test, and I'm going to proceed to working on something else. Maybe I'll do a separate video on one of those video cards that we have, but this one is urgent. And this one is the 3080. I do not know what's wrong with it. We're going to find out. And we have a Nintendo Switch board. Maybe I can work on that one next, right here. And I have a Minimax tuner. I actually have two, not one, because we just got one this morning, right here. So we'll see. Big Boss, the board is ready. Okay, so what should we do next? Nintendo or video card? You know what, since I have the Nintendo board in my hands, let's go ahead and check what's going on, and this one will be a separate video. Let's check on Big Boss. شو خالد شو صار معك؟
والله الأخبار حلوة. بعتقد زبط.
Big Boss said that he thinks it's working. Yes, we do see the light. Keyboard is on. Oh, working. Awesome job. Awesome job. We did it. Thank you, Big Boss, the boss of all bosses. And it's raining today. Awesome. One out and 6 million more to go. Look at the stuff that we finished yesterday and today. We need to invoice customers for all the stuff that we have here. PlayStation 5s, we have 1, 2. Asus laptops, we must have over maybe 12 Asus laptops here. Video cards, MacBook, Asus laptop motherboard that we fixed. This one, I think it's an Alienware, it was a no fix. And more laptops, more Asus stuff. A lot of work.